All right, so the webinar should be recording at this time. Thank you all so much for joining us. My name is Christian Koch, and I am the External Affairs Manager at Lean & Green, Michigan. And I'm so excited today to be hosting Jim Newman from Newman Consulting Group, who will be taking over the presentation in just a few minutes here for the PACE Financing for HVAC to Minimize Infectious Disease webinar. So I'm going to be going through my slides relatively quickly here to make sure we have enough time for Jim. But for those of you who don't know, Lean & Green, Michigan is the statewide program administrator for PACE financing here in the state of Michigan. As the administrator for the PACE program, Lean & Green, Michigan coordinates the PACE market by serving as the third-party administrator for the local governments in which we partner with. We coordinate the PACE market by doing a number of things, but specifically introducing new lenders to the Michigan PACE market to ensure that there is a robust selection of capital providers for property owners to choose from for their PACE projects. We also conduct contractor trainings for energy contractors to become PACE certified for them to perform their services in the Michigan PACE market. We also engage with local governments, economic development departments, and community groups to make sure that the constituents of the local governments in which we partner with know what PACE is, they have access to the Lean & Green Michigan team, and they have access to PACE financing capital. Lean & Green Michigan performs due diligence on all PACE projects and ensures that all PACE projects are in compliance with the Michigan Property Assessed Clean Energy Act. We help coordinate PACE projects and coordinate their development as needed. And we are a resource for all things PACE related. Give me 1 second while I let some people into the room here. All right. What is Property Assessed Clean Energy, or PACE? So I think PACE is definitely a number of things. I think PACE is an economic development tool. It can be seen as a way for energy contractors to bring in extra financing for them to win jobs. It's a form of green financing that can help property owners make their buildings as green as possible. But being that PACE is a special assessment on a property owner's property taxes, I think at the end of the day, PACE is really just real estate financing. It is real estate financing available to commercial property owners to make their buildings more energy efficient in a cash flow positive manner. I think two of the most important caveats of PACE financing would first be PACE's long-term fixed rate loan structure, which I think really separates it from a lot of other forms of financing, and it allows property owners to pay off their PACE loans over time through what they save on their energy bill and then come out cash flow positive. The second most important caveat, I think, for PACE financing includes broad energy conservation measures. So essentially, if an energy contractor can show that a building improvement will help a property owner save money on their utility bill, that building improvements, such as a new HVAC system, can more than likely be included in the PACE project. This is a map of all the current participating Lean & Green Michigan PACE jurisdictions. We currently operate in 46 local governments, whether they be cities, townships, or counties, covering 72% of the state's population. We have closed 31 PACE projects to date, and closing a 32nd as we speak. And we have helped facilitate over $50 million into the Michigan PACE market. Now, before I turn over to Jim, I'd just like to set the stage for him and share a bit more about why we're having today's webinar. So back in April and May, Lean & Green Michigan held 2 webinars called PACE and the Current Economic Climate, where, these were in the early days, in the early months of the pandemic, where there were a lot of unanswered questions about how the pandemic has impacted financial markets. So we really just wanted to share more with people about the trends that we were seeing in the energy financing markets and answer any questions that people had. But I think that the 2 overall themes of this webinar was, first, that PACE financing works in any economy, whether it be a good economy or a turbulent economy. Energy efficiency is one of those investments in a property that will pretty much always pay for itself. So PACE is, PACE was there at that time, and PACE is still there. So, and we're seeing increased interest from property owners, being that I think that they began to recognize that PACE served as a creative solution to help property owners tighten their belts during turbulent times. Which brings us to today's webinar. So as we've gotten a better understanding for financial markets and the role that PACE can play in the current socio and economic climate, we have also seen increased interest or a new emerging question, which is how can PACE be used for HVAC systems to minimize infectious disease? So I think a lot of my work is on the front end of project development, where I'm speaking with property owners and with developers who have this question, and this is beyond my technical expertise. So today we decided to bring in an expert, Jim Newman, who's going to share with us a bit more about this very topic and tell us a bit more about how PACE can play a role in mitigating the spread of infectious disease. So without further ado, I'm going to go ahead and give an intro to Jim, and then I will turn it over to him. Jim Newman is one of the Midwest's most experienced energy efficiency and green building experts. For decades, Jim has been promoting energy conservation and indoor environmental quality measures. Known as the Dean of Green, Jim has educated people the world over as an author, featured presenter, ASHRAE Distinguished Lecturer, lead project administrator, and trainer for ASHRAE Energy Standard 90.1, which is used by Michigan and most other states as part of their energy code. Jim has addressed architects, design professionals, building owners, and facility managers, student groups, and the media on sustainability, high-performing buildings, and green technology. So at this time, I'm going to go ahead and stop screen sharing, and if you would all like to help me in giving Jim a proper virtual welcome, feel free to scroll down to the bottom of your screen and hit the reactions button, and go ahead and hit the clapping emoji, and we can give Jim a proper virtual applause. So I've stopped screen sharing. Thank you. Stop screen sharing at this time, and Jim, you can go ahead and take it away.
Thanks very much, Christian, and thanks everybody for the applause. But I already had switched over to my presentation, so I really didn't see it. Can you hear me, Christian?
Yes, we can hear you. Cannot see your presentation yet, though.
Okay. Oh, the presentation is up.
Make sure that you are screen sharing to that presentation.
That's the problem. Okay. Oh. Okay, here we go. Are you seeing my strange screen right now?
Not yet.
Okay, I've got it up, and I hit screen share, so.
Can anybody else see Jim's screen at this time? Just feel free to answer in the chat for us. Okay, thank you. All right, so Jim, what I'm going to go ahead and do is I'm going to download your presentation, luckily, that you just sent to me, and I will screen share from my computer, all right?
So I'm going to have to tell you to advance slide?
Yes, it appears so.
Oh my gosh.
Unless if you can figure it out in the next minute or so here.
No, that's not working. Huh. I don't want to go out and come back in. Can't do that. No, I totally lost it.
All right, well, I can go ahead and take over here.
Okay.
Give me 1 second. All right, so everybody should be able to see the screen right now, correct? All right, perfect. Thank you, Mark. Thank you, everyone. All right, Jim, over to you.
Okay, so go to the next slide for IAQ. Okay. What we know and what we've known for many years is indoor air quality is not just from what's going on inside the building, it's also from the type of air that you're bringing in from outside. So we have a lot of origins for poor indoor air quality. What we're going to talk about in the beginning is existing buildings, basically, and the way things were before COVID-19, and we just have to be doing a lot more now than we used to do. Next slide. Several years ago, National Institute of Occupational Safety and Health did a 350 building study and found out that in reality, 50% of the ventilation problems, 50% of the problems were from ventilation, and 39% were from specific contaminants, and 11% they just couldn't figure out what they were. So an IAQ problem in a commercial building or any kind of existing buildings is not always easy to solve. Next slide. Now it should be, next slide should be IAQ problems. You're too far down. Go back a couple. Okay, the next one. Okay, I'm sorry. The next one is, and most of you who are on this call know this, that when we put something in, Christian, hit the down button again. When we put a piece of equipment in and it works fine when it's first put in, but green goes to gray very, very quickly. So next slide. The kinds of things we're going to be looking at that we look at every day, and we're going to be examining them in more detail today, is humidity is too high or too low. We have mold and mildew growth from various reasons. And we have either not enough indoor or outdoor air, or unhealthy outdoor air, or sometimes too much or too little air, actually. And of course, there's always water intrusion. Our rainstorms in many parts of the country are much worse because of hurricanes. But even around here, we're finding when it's raining, we have higher winds quite often than we used to have. So we're getting rain beating into buildings through the outside louvers that didn't used to happen. So let's take a look at the next slide, what we really need to do in our buildings. For those of you who are building owners or facility managers, communication and looking around your building and seeing, we've done energy audits in buildings in the middle of the winter where people are sitting there with, just a shirt or a blouse on, or they've got jackets on, and some of them, as you can see, have scarves around their necks. So if the amount of air that's coming into a particular area isn't quite right, it's even worse with COVID-19. Next slide. So let's look at the HVAC system. The IAQ problems with the system itself, the system can be a source of biological contaminants. There's all kinds of surface contamination in the system, whether it's in the unit, whether it's in the ductwork, whether it's in the rooms themselves. And of course, there's always odors. There's a thing called dirty sock smell in the HVAC industry, which some of you may know. And that's when a cooling coil has too much biofilm on it and is loaded with particulate. And when it's first started up in the morning, the people who are there are not real happy. Next slide. So the unit itself, we have a number of problems. The drain pans can be loaded with fungus because especially in older air handling units, the drain pans were flat and the condensate drain was welded on the side of the drain pan, and it was typically anywhere from 3/4 of an inch to an inch above the bottom of the drain pan. So there was always that amount of water in the drain pan in the summertime. And in your unoccupied areas or on weekends, if buildings were totally shut down on Saturday and Sunday, fungus and mold and bacteria would grow in that drain pan. And when you started up your HVAC system early in the morning on Monday, everything that was in there would aerosolize and be transmitted into the space. So let's look at a couple of things that can happen. These are existing buildings. Next slide, please. Existing buildings that we've done audits in, and these are some of the pictures we've taken. A really big one, in the economizer, if the dampers are not maintained well, they typically won't work very well. We've been in buildings, we were in a building on a campus, which shall remain nameless, a couple of years ago, doing something for DTE, and it was a 4-story building with an air handling unit on each floor. So as part of our audit, of course, we look at the filters. The filters looked pretty clean. They had been changed recently. They were good. But when we looked at the filters, we were looking at the economizer section 2. And these units were variable frequency drive units. And the first unit we looked at, this is now the middle of winter, remember, the VFD was running at 56% of its normal speed. Well, it shouldn't be doing that in the middle of the winter. It should be running at about maybe 40 to 45% because you don't need as much air in the wintertime as you do in the summertime. So when we opened the filters, we figured, well, the filters are probably plugged. No, filters were fine. When we looked at the dampers, the outside air damper was about 40% open. With a 40% open outside air damper, you're getting 60 to 70% of the outside air because there's no resistance at that end. So during the unoccupied cycle, they were bringing, when they should have been bringing 100% outside air, they were bringing 60 to 70% outside air and bringing this 20 or 10 or 0 degree air in and causing a lot more energy problems in their building. And it was stuck. It didn't move when we shut the unit off. It didn't go to closed. Third floor was pretty much the same. Both damper operators weren't working. They weren't working at all. We went to the second floor and it did go try to close, but it only went to 30% closed. And the bottom floor, the first floor, the outside air damper went all the way closed. The return air damper went all the way open, but it was an older system and the outside air dampers didn't close very tightly. So they were pulling in about 15 to 20% outside air with the outside air damper totally closed. These are the kinds of things that happen. These are the kinds of things that facility managers and building engineers need to be very aware of, and they are, but too often we have, especially in schools, for instance, and or even college campuses with many buildings, one person or two people that have to handle all the buildings or all the schools. That just doesn't work. And when we talk with building owners, we tell them, you need to think of your building maintenance team as an asset, not an expense. They really aren't an expense. They can save you a lot of money. So let's look at filters, which will be the next thing we'll be talking about. Here's a couple of examples of filters with little or no maintenance. Next one. When you have a filter that's totally loaded and you have a fairly high static pressure system, like over 4 inches, it'll rip the filter apart. Well, obviously, there's no filtration at all. Or on the next slide, we'll see improper filter installation. If you have gaps where the filters are, and these are bag filters, so they're very efficient filters, but they weren't put in properly, and the air is going to go where it's easiest for it to go. So it goes between the filters, and you're not getting very much filtrate. You're not getting any filtration on the air that goes through. And the next slide will show you what happens to the coil when things like that happen. Originally, filters, all they did was protect the coil in the system and keep it from looking like this. When a coil looks like this, it's not getting enough airflow through it, and the heat transfer efficiency is way down. So the chiller or the boilers are working a whole lot harder. And on the next slide, we start learning about what we need to do before we really get into COVID. And These are the kinds of things we need to do just in a plain old ordinary building in plain old ordinary times. And these are much more important. Remember that green goes to gray slide. That happens very quickly. And we'll be talking about coronavirus pretty soon. And it's much more important that you be more careful, or the building engineers and maintenance people be much more careful today than they were a year ago. So when there is an IAQ problem, they're not always real. Sometimes it's a perceived problem. Somebody has an issue and they think there's a problem with the HVAC system, and they start talking to the person in the next cubicle or somebody else at the coffee machine or whatever, and pretty soon there are two people that think there's a problem. And then those two people talk to other people, and 2 goes to 4, 4 goes to 8, and pretty soon you have what we call mass psychogenic illness. So the real problem here is, if it's really only a perceived problem, that's a reality to the person who thinks it is. So you have to identify the problem if there really is one, and make the necessary corrections as soon as possible. So the next slide will show who's actually blamed for poor IAQ. Hit it again, Christian. Most of you on this call are probably on that list. So if there is a IAQ problem, and we're expert witnesses in a number of IAQ cases, everybody is called in. When we first started doing LEED certification of buildings, I wasn't carrying errors and omissions insurance. And in talking to a few people, I finally decided I better do that, because if there is a court case, even though we didn't have anything to do really with the design, we were just the lead project administrator, we would be in that lawsuit. So I now carry E&O insurance. So when should an owner seek outside assistance? That's the next slide. Well, sometimes when there's a real problem or even a perceived problem, it's complicated to figure out what's going on. Or you've tried to mitigate it as a building owner and it's been unsuccessful. There has to be some air sampling, and there could be problems if you wait too long to do it. And the other thing that sometimes happens is people don't always trust the owner or the facility manager necessarily of the building. Am I still on? No.
Yes, yes.
Yes. Oh, okay. Okay, good. Because I'm not seeing what's on the screen. Shoot. All right. So let's go to the next slide, which will get into what we're going to talk about relative to coronavirus. And I can't see the slides, Christian, so I'm just
All
going
right.
to assume.
So this slide is coronavirus and COVID-19.
Yeah, okay. And there's 4 bullet points on it?
Correct.
Okay. This is what we're going to be talking about for the next basically 25 minutes or so. So the next slide shows, and you're going to know these first slide or two, you'll know this, how COVID-19 spreads. We know it really spreads now through aerosols. That's the biggest way this doggone COVID-19 spreads. And so we're not going to spend a lot of time on this because you know all this. So let's go with the requirements that are being recommended by ASHRAE and CDC. One of the things it says to do is flush with outside air, 100% outside air, for a minimum of 4 hours. And if you can't do that, do maybe 2 hours at a time with 50% outside air. And we'll talk about some of the issues and the problems associated with that. Then we'll be talking about filtration. We'll be talking of other methods of controlling as best we can this COVID-19 virus. And we'll be talking quite a bit about humidification and what it does. So let's start with the next slide about filtration. And a lot of what is being talked about is raising the MERV rating, the minimum efficiency reporting value rating of the filter, and going to MERV 13 or 14 filters. Well, here's one of the problems. Most air handling units, air handling systems, have MERV 8 filters in them. MERV 8 filters are much better than MERV 4 or 6 because they'll take out slightly more than bumblebees and golf balls, but they're not really wonderful filters. So a lot of people have gone to MERV 11 filters, which is a much more highly effective filter, but now it's being recommended to go to 13. Well, the difference in pressure drop between MERV 8 and MERV 13 is considerable. From 11 to 13, it's not quite as bad, but the difference in cost between MERV 8 and MERV 13 is about 4.5 times. From MERV 11 to MERV 13, it's about 2.5 times. Plus, with the MERV 13 filter, since it's more efficient, you're going to collect a lot more on it, and it's going to have to be changed more often. Most buildings, especially today during COVID-19, they don't have the people in them. A lot of the tenants aren't coming back. And buildings typically don't make money until they get over 65% occupancy. Some of them that are more costly don't make money until they get to 80% occupancy. Well, as some of these leases are being reneged upon or people aren't paying their rent or what have you, they don't have the money to pay 4.5 times as much for filters and change them more often than they used to. And the other thing that you see a lot, and we're working with Michigan Department of Education and Eagle, and people are asking, well, should we put in HEPA filters? Oh my gosh, you can't put HEPA filters in normal air handling units because there's no room for them, and you wouldn't want to anyway, because then you'd hardly get any airflow in the building because it's a very high pressure drop filter. So anytime you hear somebody recommend that you should put in a HEPA filter, you really should know they probably don't know what they're talking about. So we'll be talking about some of these other things because we're talking not just about filters, but methods of inactivating the coronavirus itself and inactivating bacteria. And some of these methods are carbon or ultraviolet and ionization. The next one under HEPA filters is polarized media air cleaner, which is a good way to collect particulate and also to reduce VOCs and odors, but it doesn't really do much relative to inactivating a coronavirus. And carbon filters are nice for removing odors, but they do nothing for inactivating a virus or bacteria. So the two that do, though, are ultraviolet, and you've probably heard and seen a lot about ultraviolet because it is one of the older and relatively efficient methods of inactivating bacteria and viruses. But it has two issues, and we'll be talking about that in just a minute. So if we go to the next slide, we'll see a chart that we developed. And since we developed this chart about 4 months ago, we revised it 6 times, and we're going to go through another revision very shortly. But for now, the first few that we have on there are the ionization. Then the next one is ultraviolet. If you go across to the right, we have media filtration, then polarized media, then chemical. And then some people, because of particular odors in a space, are still use scent generation, which is just a masking of an odor. But if you look at the UV and you look at the various titles on the left-hand side, you'll see all the yeses, you'll see a couple of nos, you'll see it depends, and we have notes 1, 2, and 3 at the bottom of the chart that talk about that. So what we're saying where we have a note 3 is you really have to look very carefully at what is being recommended by a manufacturer or a salesperson. Because a lot of the marketing that's done by manufacturers, as most of us who've been in the HVAC business for a long time know, tends to sometimes be a little bit, let's just say, overboard. But you need to look at these kinds of things. We have come to the conclusion, although ASHRAE is not recommending it at this point because they say there's not enough third-party validation, but that is happening very, very quickly on these ionization procedures. And bipolar ionization is the one that we happen to think is the best way to go if you're going to go with ionization. And the next slide will show how it actually works. Everything that's going into the filter, into your unit from outside air and return air, has positive and negative ions in it. The bipolar ionization puts positive, negative ions of its own out into the space that combine with these that are already there. So the particulate gets somewhat larger, and it then can also, because it interfaces with the bacteria and the coronavirus. And by the way, tests have been done on a virus that is very, very similar to coronavirus, because nobody, of course, wants to put coronavirus into their testing facilities, into their labs, into their test ports. But they know that this particular virus that's being used has pretty much all the characteristics of coronavirus, and it will do to SARS-CoV-2, which is the more scientific name, a medical name for COVID-19. It will pierce the outside of it and inactivate it. Then we also have the next slide, we show UV. And you have to put a number of UV lamps, not just a lamp, UV lamps, either upstream or downstream of typically the cooling coil. This shows that the filters are on the left, so it's upstream of this particular cooling coil. And you have to have several lamps there because there are two issues with ultraviolet lamps. One is how close does the airstream go to the plant, to the lamp? And number two is how fast does it go by the lamp? So you can't just put 1 or 2 lamps in a large coil. Some of the manufacturers also have what would we call it? Something above it that will reflect the lamp, and they put it horizontally above the drain pan. So what I talked about earlier about drain pans getting kind of messy over a weekend, for instance, they will kill a lot of that bacteria and virus and fungus that develops in the drain pan. So that pretty much takes care of filters and the other types of systems. And the next slide will go to IAQ problems, to winter humidity primarily. And if you look at what we're showing here, the optimum humidity is around 50%, but typically in the wintertime, we've got buildings that are drier than the Sahara Desert. They're under 15% relative humidity. And you may see scenes like this woman putting eye drops in because her eyes are dry. So let's look at what happens to pathogens in the next slide when the reheat is less than 40%. This is from Dr. Stephanie Taylor, who is one of the people on the ASHRAE infectious aerosol document, had quite a good team. And she was one of the members of that team. We have talked, we have sent slides back and forth. And when relative humidity is less than 40%, this is what you're seeing. And we'll see it in more detail, I believe, in the next slide. No, a couple of slides from now. But let's look at the next slide, and it shows a chart that we in the ASHRAE Detroit COVID-19 Task Force have modified somewhat, because the chart actually shows the chart that ASHRAE uses shows 40 to 60% as being the optimum, but we realize that most buildings cannot get anywhere near 40% in the wintertime. And if they had 40% in most buildings again, and especially those older ones with single pane or with poor insulation in the walls, you have 40% humidity when it's 10 degrees outside or 0 degrees outside, you're going to have some real problems in your building, because you're going to have condensation all over the windows. You'll have moisture going into the building envelope, into the walls, and coming out on the other side. And you see a lot of schools, if you go by a school or your kids go to a school with a swimming pool, you'll see a lot of white on the mortar and on the bricks on the outside of the brick. That's the moisture escaping to the outside of the building. Not a good thing. It means they don't have good dehumidification in the pool. But these are the kinds of things that happen to a somewhat lesser extent when there's not a pool. And if you look at all the things that go on, the bacteria, viruses, fungi, mites, et cetera, down at 0 to 30% or 0 to 20%, they're pretty high. And they also get high again on the right-hand side in the summertime when you're over 60%. So these are the kinds of things we have to watch out for. And if we go to the next slide, we'll see what happens with these infectious droplets. You know, we talk about this 6-foot distance. And 6-foot distance is where these larger droplets actually will go out. And then as they get smaller, they go further and further. Notice the distance traveled at the bottom, and stay in the air a lot longer. That small 0.5 micron particle, 41 hours to 21 days. 21 days, it's in the air that people are breathing, unless, of course, these smaller particles, as we hope they would, get caught up in the airstream, brought back through the return grill, back to the air handling unit, to a good filter or a good other system that can, like I say, inactivate the virus. And with a lot of these systems, more than just a filter, and even with high efficiency filters, the 11s, the 13s, some of these viruses will get trapped in the filter. Now, those filters with, whether it's UV or bipolar ionization on the discharge side of the filter, will inactivate more than what gets through the filter, let's say that. Will inactivate what gets through the filter. And the ionization ones will actually send these positive and negative ions into the space to interact with other positive and negative ions, which are viruses and bacteria in the space. So the combination, excuse me, of a higher efficiency filter and either ionization or UV will help a lot with COVID-19. Let's look at the next slide, which is a slightly different way to look at relative humidity. And it again talks about this 40 to 60% with the infectious droplets settling out in that basically 6 to 8 foot range. But the other things, you have to have good cleaning. And when you put a disinfectant on a surface, if the surface is dirty, it doesn't do much good because you've got a biofilm on that surface. So the thing that you really need to look at here, and I'm not sure what does this next slide show that that one about everybody who gets called into a lawsuit, Christian?
The next slide here says, remember, it says PACE can help pay for these retrofits.
Okay, okay. So we are obviously approaching the end of my part of this. And that slide talks about what Christian talked about at the beginning. PACE can help pay for these various retrofits because reducing the threat of COVID-19, the people who do PACE here, Lean and Green, Michigan, and in most of the other states have decided that if you do things to reduce that, they're going to help pay for that. And some of these systems, and you have to get into some heavy ASHRAE stuff with a design engineer who can do IAQ modeling and that type of thing to know that you can actually reduce this 100% outside air back to close to a minimum airflow or even to a minimum airflow when you use the UV or the bipolar ionization. You can do that, but you have to do some rather difficult ASHRAE evaluation to be able to do that and to know you can do it and to basically tell the state or the municipality that the building is in that yes, we are doing that in accordance with ASHRAE standards and guidelines, and this can be done. So the next slide will show a number of resources, and we put ours at the top, newmanconsultinggroup.us/websites. And if you go to that particular place in the Newman Consulting Group site, our very first websites are all related to COVID-19. So you can get a tremendous amount of information there. And then there are many other government and industry resources. So again, the next slide once again reiterates who is blamed for poor IAQ. You have to hit that one twice probably. So you need to remember that because whoever you may be on this call, many of you can get involved in an IAQ legal case. And litigation is no fun. It costs a lot of time and it costs a lot of money. And some of the people who are on this call who are attorneys would not take issue with that, I think. So the next slide, I believe, has a quote from a recent president of ASHRAE. The greatest challenge we face today is failure to adapt to change. And this was said long before the pandemic hit the world. And this is what we have to keep in mind. We have to keep in mind that green goes to gray very quickly and that PACE can help do all these things that will make a building safer and more comfortable for people to be in. This last slide just shows some of the organizations with which I'm involved. So we can go to, if you would, the chat, which I can't see. Okay, are there any questions?
All right, so nothing in the chat yet, but at this time we will turn over to questions. I'll wait just a few seconds for you guys to think of any questions that you might have. Feel free to either turn yourself off of mute if you have the capability to do so. If not, you are more than welcome to drop your questions in the chat. So I will pause just for a moment here in case anyone has any questions.
I have a question.
Yes, Mary, go ahead.
Do you have to purchase a new, like what's the cost associated with making that bipolar upgrade?
It really varies on the building. Most of the some of the manufacturers have systems that basically go into the HVAC system that's serving the building. And they also have units that can be put into small fan coil units or PTAC units. We're looking at doing something with the Ronald McDonald House, and they have a little fan coil unit in every one of the rooms where the families stay when their kids are at Children's Hospital. And So we talked to them about doing that. And there are people or organizations, companies in Southeast Michigan that are familiar with bipolar ionization and UV and can do the installation. But to give you an actual number in a webinar is pretty much impossible to do. You could probably look at, and this is going to be a big range, 50 to 80 cents a square foot.
And so it's something that you add on to the existing system. It's like a physical thing that you attach or add on to the existing system. You don't replace the existing system at all.
No, that's correct. It's an attachment to an existing system. So we're talking to schools now, as I said, with MDE, and a lot of the older schools have unit ventilators in each of the classrooms, and it can be put into an individual unit ventilator for a classroom. There also are portable units that can be used. And the portable unit, we get a lot of calls about this because people don't have central air handling systems. And, you know, is there a portable unit that we can use for this? Well, my daughter in Los Angeles is an acupuncturist. She bought one of these for the small room that she does acupuncture in. And if you go to your dentist or your doctor, you'll see a lot of those offices have these units. The better ones have HEPA filters in them and either a UV lamp or bipolar ionization or some type of ionization also in that portable unit. So there are portable units you can use if you have a building and many religious institutions don't have, some of them don't even have air conditioning. So they don't have central systems and they are buying them to put in the offices and where the people pray on, typically on the weekends. Good question. Thank you for that.
All right, thank you, Jim. Thank you, Mary. So we do have two questions in the chat. Not sure if you can see them, Jim, but I will go ahead and read off the first one that came up. This one is from Anna Maria, and the question is, do these improvements on their own really qualify for PACE financing? Are they intrinsically increasing energy efficiencies and or creating savings?
Okay, that's an excellent question, and it's one that I'm glad you asked. That's a yes and no. So we talked about MERV 13 filters, for instance, which are much more expensive, higher pressure drop. Air handling units will have to be increased in speed if they can be. If it's a low pressure system and people do put in MERV 13, and we just talked to a school the other day that is in the process of doing that, and now they're wondering if they made a mistake. But that would actually increase the energy use. But many of these systems, like I had said, ionization and UV, if you use a particular ASHRAE method of calculating indoor air quality and how much outside air you really need to bring in, they will reduce the energy considerably over what needs to be done if people start using 100% outside air a lot of the time. Because when you use 100% outside air, and we wrote a blog on this very recently, so if you go to our website and go to blogs, the last few blogs are all about COVID-19 and HVAC systems. What happens when you're bringing in, think about the summer we just went through, we had a number of days that were above 90 degrees and very high relative humidity, like 70% relative humidity when it's above 90 degrees is extremely uncomfortable, but also puts a huge load on the chillers, on the air conditioning system itself. And rooftop units or chiller systems typically can't handle that kind of airflow at 100% outside air. So what happens is, instead of delivering 55-degree air to the space that makes people comfortable because it they want it to be around 72 or so, depending on the person, whether it's ±2 or ±5, but whatever. The air conditioning system can't handle it, and the building will eventually get to be closer to the temperature of the outside air coming in, minus what the chiller can bring it down to. So if you're bringing it down to maybe 70-degree air or 72 or whatever, rather than 55, it's going to be a very short time before people are very, very uncomfortable. And most of them are going to end up going home. Same thing in the wintertime. They'll be too cold because the boilers can't handle it, or the gas-fired heating system can't handle it, and they'll be cold all the time. You might get building up to 50 degrees if you're bringing in a lot of 0-degree air, and that would be about as far as you'd be able to get it. And we have a blog like that talks about that in a lot more detail on our website. I hope, did that answer the question, or do you want to go further?
No, thank you very much. I appreciate your giving that insight, because we kind of struggle with, whether or not something like that would, really qualify as PACE. And so I guess some of it depends on the legislation state by state as well.
That's also true. Yes, that's also true. Are you from Michigan?
No, actually, I'm from Illinois in the Chicagoland area, Jim. We may have spoken in the past. Hi.
Is this Helen?
No, this is Anna Maria Kowalik with Inland Green.
Oh, yes, I think we have.
Yes, that's right. Good to see
Okay,
you.
well, yeah, Illinois and Chicago have a pretty good PACE program, and it really is going to be a decision probably of the legislature or of your PACE administrator.
Yes, in which I'm also involved as well. So thank you very much.
Oh,
I
good,
appreciate
good.
the
You
insight.
may have some input to that, Anna Marie.
Well, we'll see one day.
Oh, right, okay.
Yes, thank you for that question there, Anna Maria. I think that was an important question, one that we have also been talking internally over at Lean and Green Michigan. And I think that you basically summed it up, Jim, when you said that a lot of it comes down to how the state statute is written for PACE and what the administrator says in your state. So we've got a second question here. This one is also kind of a comment. So Rochelle Downs, if you could maybe clarify for me what you are referring to, because that question came in earlier. So I apologize that I don't recall what it was about. But the comment says, I just saw one at my dentist's office yesterday. Where can we purchase them? Do you have a reputable vendor to recommend? That was on portable units, Jim. Thank you.
Yeah, no, I figured that as soon as you said dentist office. Because I was just at my dentist office about 6 weeks ago, and wow, they really do a job. Actually, the best thing you can do, because there are so many manufacturers and we really haven't decided on a particular best one, but I'll tell you two things. And we already mentioned one that should have a HEPA filter, and it should have UV or ionization in it also. And you can find prices ranging from about $150 to about $900. Obviously, the $150 ones are not going to be very good. They typically have just a filter in them, because to have something better in it gets a little pricey. So look at maybe, if you don't want to spend $800 or $900, look at the $300 to $600 range when you're looking at them, and make sure it's a HEPA filter and ionization or UV lamp.
Got it. Thanks, Jim. All right, so we have a few minutes here, probably enough time for, I'd say, 2 more questions. The next one in the chat here is from Richard Doherty. Richard asks, how do we work these systems into a project for a new building? What is the best way to evaluate state-of-the-art HVAC systems as it relates to COVID-19 and potential other pandemic pathogens?
Oh, that's boy, these are great questions. Wow. we're actually doing a new building in Clarkston, a Comfort Inn hotel that we've been working on for over a year now, and is finally starting to get built. And a lot of people are looking at, I'm talking design engineers now, the mechanical design engineers who design the HVAC systems. And also, obviously, architects are considering it considerably too. But you need to look at putting what we've been talking about in the past hour, pretty much, into the HVAC system. And a lot of people are already doing this. We had I think I mentioned we have Detroit ASHRAE has a COVID-19 task force, and we have a number of really good people on it. And there are architects or engineers who are, let's say, architectural engineering firms or design engineers who are designing UV and ionization right into the HVAC system. And we're doing that in this Comfort Inn in Clarkston too. They're putting it right in when they put the HVAC system in, they will put in they're going to use bipolar ionization, and they will be putting it in whether they have the manufacturer put it in or whether they put it in after the unit comes in. I don't know which way that's going to work. But that is definitely happening. And I think I didn't fully answer that question. Did I?
The question again is, how do we work these systems into a project for a new building? What is the best way to evaluate state-of-the-art HVAC systems as it relates to COVID-19 and potential other pandemic pathogens?
Okay. Well, one of the things I would recommend, a couple of things. Number one, in a new building, this Comfort Inn in Clarkston, PACE is a part of the capital stack. So PACE can very definitely be involved in the design because it may be a tad more expensive. Not maybe, it will be a tad more expensive. The other thing I would recommend is commissioning the building, having proper commissioning on the building during and after it's done, and getting a TAB contract, testing and balancing contractor in there to make sure the airflow in all areas is proper. One of the studies that came out of actually Wuhan in China was a restaurant where a person who had COVID-19 was sitting with a bunch of people and was in a particular area of the restaurant that got good airflow. And as he was talking, coughing, whatever, his contagious aerosols and droplets were coming out of his mouth, obviously. And quite a number of people in that area of the restaurant got infected with COVID-19, but in the rest of the restaurant, they didn't, because what was going on with the airflow in that area was being re-entrained into the air handling system and wasn't traveling to other parts of the restaurant. There was another very similar one that happened in the United Kingdom, and it was the same reasoning. So having proper testing and balancing done to make sure the airflow is proper in a lot of areas is, in these days of the pandemic, and there will be more of them, very, very important. We actually were asked to be an expert witness in a case a number of years ago where people were complaining in a major building. They were in a basement area, actually, with no windows. And they were complaining they weren't getting enough air. And we were asked by the owner of the building, well, we gave them some ideas and some recommendations, let's just put it that way. And about 6 months later, we got a call from an attorney's office asking us if we would be an expert witness in a case for that particular building where people were complaining. Actually, no, we weren't, no, that's not right. We were asked by an attorney of the building owner if we would be an expert witness. And we told that particular attorney they really didn't want us as an expert witness because we'd already examined the building for the building owner, and there's a problem there that needs to be fixed. So we were kind of protecting the building owner because it was a good client of ours. And there was no way I wanted to be on the stand unless they had fixed it, which they hadn't, which is why they had a complaint. So I made it very clear that they needed to fix it because they were going to get clobbered. And they did. So that made me feel good.
Thanks, Jim. So it is after 11. So if anybody would like to leave at this time, I do want to be conscious of people's schedules. As I mentioned earlier, this webinar is being recorded, and you guys are welcome to view it later. But we did have one last question come in. Jim, I'm curious if you can stick on for just a few more minutes and maybe feel
Sure,
more.
absolutely.
All right, great. All right, this question comes from Philza Walters, and the question is, when commissioning first started, it was at the tail end of the project. Now retro commissioning and conscious commissioning is used. Is there a similar form of evaluation to evaluate if pace and IAQ improvements can be achieved simultaneously? Who is doing this kind of consulting nationally?
Good question, Philza. Thank you. What we try to do now is not just commission at the end of a project, because then it's already a little late. I mean, we're still doing good because we're making sure that the system has been put together and is operating properly as per what was designed. But with LEED, we have something called enhanced commissioning, where the commissioning agent actually gets involved from the very beginning and makes some suggestions as to the design of the systems. So we recommend that when anybody hires us, whether it's for an energy audit or to do a LEED certification or whatever, that it be done at the beginning and through the entire retrofit project, and again at the end. And we find that to be very, very successful. And what it does, I was going to say it eliminates, but this doesn't necessarily eliminate. It minimizes what has to be done by the contractors, being HVAC contractors, being control contractors. We minimize how much finger pointing there is being done. And we also minimize the amount of work that the contractors have to do at the end of the project. There are national companies that do this. There are many companies that do it locally only. We happen to be one of those. But there are many national companies that are all over this country that will do it.
Excellent.
I'm not going to mention any because I would only mention one or two, and then I'd have a lot of people upset with me. But if you want to talk later, Phil, so we can talk.
Yeah, Jim, actually, if you wouldn't mind, just go ahead and maybe drop your email and contact in the chat here as we finish up, and then
I can't hit the chat. I've never gotten back to the to be able to get into it. I didn't want to try again because then I knew you'd lose me.
Sure.
So it's on the next to last slide.
Oh, yeah, yep, found it. Okay, got it. So here's Jim's information here in case if anybody would like to follow up with him and chat more.
And I'll just say it while Christian is writing it. It's Jim N at Newman Consulting Group.us, and Newman is NEWMAN. So Jim N at Newman Consulting Group.us. But I urge you to go to our website and take a look at some of the blogs and articles we've written, because we have a lot on there relative to what we discussed today. We also have some case studies that show energy audits and show PACE projects that we've done, and also, of course, LEED projects that we've done. But PACE took a long time to get started. Andy Levin first started it, and it took about 4 years before the first job came, because that's the way it works. And now it's going like crazy. People are finally realizing that it's
So
really,
very relaxing and peaceful. Digging in the dirt.
Go
Oh,
ahead and mute Nancy. I don't think that was a question.
okay, I heard an interruption there, Christian, but I didn't quite catch it.
Yeah, I don't think there was a question. Nancy, if there was a question, go ahead and unmute yourself. But I assumed that you just accidentally turned yourself off of mute. So at this time, we are eight minutes past. So I'm going to go ahead and end it here. I do have Jim's contact information on the screen here. I also dropped my email in the chat in case anybody has any other follow-up questions in regards to PACE financing. But Jim, thank you so much for joining us today. I learned a lot. I'm very excited to take this knowledge back to many of the property owners that I've been in contact with recently. And I also want to say I really enjoyed your you had mentioned green goes to gray, and that's going to stick with me, and I really like that. So
Yeah, we use that in a number of our presentations, actually.
I like it. All right, thank you all so much for joining us, and enjoy the rest of your day. All right.
It was a pleasure, Christian. Thank you.
Thank you, Jim.
I just got to get off. Ah.